A problem. Find the recurrence relation and the initial conditions for an, the number of bit strings of length n, which contain 3 consecutive zeros. Find A4. First, let's start with the initial conditions. A1. Here the bit string has length 1, so it cannot have 3 consecutive zeros. It means A1 is 0. Similarly, A2 must be 0. A3, there is only one bit string of length 3 with 3 consecutive 0. So this is the string 0, 0, 0. So A3 is 1. And these are the initial conditions. Now assume that n is at least 4, and we want to find a recurrence relation for an. The number of bit strings that satisfy these requirements can be split into 4 classes that are disjoint. In the first class, we consider the strings of length n that has last bit 1, so the end of the string is 1. In all other subcases, all other subsets, the last digit will be 0. But they'll differ this way. In the second class, the last 2 digits are always 1, 0. And here, the last 2 digits in these 2 classes are 0, 0. In class 3, we'll have 1. And in class 4, here we'll have 0. So the end of the string is this in class 1, this in class 2, this in class 3, and this in class 4. Obviously, these classes are disjoint. The classes are disjoint. Yeah, here the last digit is not 1, not 1, not 1. Here, the last 2 digits are 0, 0. Here, 1, 0. So these two are disjoint. And these two are disjoint because they differ in the third last position. The addition principle then says that an will be equal to the number of strings in class 1 plus the number of strings in class 2 plus the number of strings in class 3 plus the number of strings in class 4. Here, the number of strings is an minus 1. The number of strings of length n minus 1 that contain 3 consecutive 0. If to each such string we add 1 last bit that is equal to 1, we obtain just the strings of class 1. Similarly, this number is an minus 2, and this number is an minus 3. And here, if we append any bit string of length n minus 3 with 3 zeros, we'll obtain a string that satisfies the requirements of the problem. No restrictions for the strings of length n minus 3 here, which means that we have 2 to the power n minus 3 strings of length n minus 3. So these are the number of strings in the 4 classes, and this gives us a recurrence relation. An is equal to an minus 1 plus an minus 2 plus an minus 3 plus 2 to the n minus 3. And this is for any n greater than or equal to 4. Now we can obtain what we say 4. Just replace n by 4 here. Four minus 3 is 1, so this is 2 to the first, just 2. And we already know that A3 is 1, A2 is 0, and A1 is 0. So yet that A4 is 3.